Hi everyone, this video here will focus on the relationship between displacement, velocity and acceleration. The topic here is rectilinear motion. So this is some really important stuff that Newton came up with, and we've already talked about the relationship between displacement, velocity and acceleration. You can see it along the top there. Displacement, if we differentiate we get the velocity, differentiate again we get the acceleration. This little unit here only deals with objects that are moving on a straight line and only two directions being possible. So this is a really simple case of motion to consider. We're not talking about things in 3 dimensions, just very kind of one-dimensional here. Makes it nice and easy to analyse. Once we have this stuff down, we can move on to harder things. So first of all, in terms of the displacement, you've got the origin here. Everything to the right is positive, everything to the left is negative. Then you've got velocity. Scroll down here. So you've got velocity. Anything heading this way to the right is positive velocity. Everything heading to the left-hand side, the velocity is negative. So let's just look at body A here. It's sitting. The displacement is +5. Its speed is +5. Its velocity is +5. Body B, its position is 10, the velocity is -3 because it's heading back towards the origin. Body C, position is -3, it's heading towards the origin, or it's heading this way to the right hand side, so therefore its velocity is 10. And body D is at -6 and its velocity is -2 because it's heading that way. So it's good to know those conventions for displacement and velocity. Let's look at this real simple question. A body moves in a straight line such that its displacement from an origin at time t is given by that. Find the displacement, velocity and acceleration when t equals 2. So it's a real simple matter to go through this, guys. We understand how to do the derivative. We know that that represents velocity. So if we do the derivative, for displacement first, when t equals 2 we get x equals 9. The velocity is just the derivative, so we do the derivative, 6t squared minus 5, substitute t equals 2, and we would get 19. And the acceleration, do the derivative of the velocity, is 12t. So when t equals 2, the acceleration is 24. Now you can see there, this is how you would do it on your calculator. Here's another one. A particle initially at the origin O, it is projected away from O and moves in a straight line such that its displacement is given by that. Okay, so there's the displacement in terms of t. We want the speed of the particle when t equals 12, the value of t when the particle comes to rest. Let's have a go at answering these questions. Okay, here's the answers. The speed when t equals 12. So speed is the derivative. So we do the derivative, get 10 minus 2t and substitute 12 in there. The velocity is -14. That just means that it's heading to, if you're looking at your page, it's heading to the left. It's heading that way at a speed of, at exactly the moment t equals 12, the speed is -14 meters a second. Okay, so even though its displacement may be positive, it can be heading to the left. Next question. The value of t when the particle comes to rest. So we want to know when the velocity is equal to 0. So we solve 10 minus 2t equal to 0, so that's at t equals 5. At that exact moment, when t equals 5, we can substitute into our original displacement equation. We're at 25. So 25 to the right, if you like, that's when it's stopped. Last question, the distance the particle travels from t equals 3 to t equals 6. Well, you know how to do this. We've talked about integration in this one here. So let's go through the answer. The distance between t equals 3 and t equals 6. Okay, when t equals 3, if you substitute 3 into the original equation, we get 21. So it's sitting here at 21. When t equals 6, it is at 24 meters from O. So we substitute t equals 6 into here. Right, our answer to the second one says that it's stopped at t equals 5. And this is where it gets tricky. At x equals 25. So from t equals 3 to t equals 6, it goes from A to C where it stopped, and then it goes back towards B. Right? So the total distance, 21 to 25, which is 4, and then another one here, the total distance it travels is 5. So this is the representation of rectilinear motion. This is the thing you need to understand to get from one to the other, differentiate, and then integrate to go back the other way. So a particle travels along a straight line. Now we're given the velocity. The initial displacement of the particle, the line is 5 meters. Find the acceleration when t equals 3. So acceleration is the rate of change of velocity. So we do the derivative. The derivative of the velocity is 12t. When t equals 3, substitute down, we get 36 meters per second squared. Notice the units. Make sure that you're using the correct units here. That's important. So we want to know the displacement. So the displacement is just the integral of the velocity. So we do the integral. We get 2t cubed minus 3t plus c. We need to find c here, and the information is up here in the question. The initial displacement. Initial displacement here means when t is equal to 0. So when t is equal to 0, x is equal to 5. This allows us to find c. C is equal to 5, so we substitute 5 in there, that's the displacement, and t equals 0, so C is equal to 5. So now we've got the full equation for the displacement, and now I can substitute in when t equals 5, we get x equals 240.